Good evening, everyone. So, myself, Dibyansu, and we are starting. I'm starting. Basically, I'm starting maths of NDA. My mathematics will be based on this examination. So, basically, if we talk about the syllabus of maths in NDA, so it covers completely class 11th and 12th mathematics. So we'll start with this. So today we'll take up a class of basics of set theory, and after completing this basics we'll get into and we'll solve some questions, and after that we'll continue with our preparation for mathematics. So let's not waste our time much and let's start with our topic, that is set theory. So gentlemen, let's start with set theory. So what So just now tell me what comes to your mind first when you listen the word set theory. So actually you will not be able to tell me what comes in your mind because we are not in an offline class. So you just think in your mind what comes to your mind when you first listen this word set. What do you mean by set? If suppose you can understand by this example. If you take some real life examples. So when you go in some shop where utensils where utens when you go and shop for utensils or some furniture shop, so you tell me so you tell the dealer or tell the vendor that भैया sir please give me a set of या फिर give me a dinner set, give me a set of plates. So what does this set means? So set is actually what? This is actually collection of some well defined distinct objects. Well defined distinct objects. So what does this well defined means? What does this well defined means? Now when I say some well defined things, then what does this well defined mean? What does this well defined mean? Just think in your mind. What does this well defined mean? So actually this well defined means something. If something is told, or if we are given a set, and if suppose if you have taken a dinner set from some utensil shop, so if a glass comes on, suppose, so you'll be able to figure out whether this glass is present in that dinner set or not. So this is what well defined means here. This is what well defined means here. If something is given, if some object is given, then we can figure out or we can find out that whether this thing belongs to that set or not. So this is what well defined means here. Okay gentlemen, so if I think now I'm very clear with this what this set is. So now let's move ahead and let's go ahead and talk about how to represent these sets. See gentlemen, as you are preparing for NDA, so it is expected that you already know the basics of class 11th and 12th maths, at least not even 12th, then at least class 11th maths. And if you are an appearing student, then it is also expected from you that you you have already studied class 11th maths. So I'll not be taking that much of basics here because that will really take a lot of time and we have very less time. So I cannot go with very few small things. So we'll just go with this. So now let's talk about representing this set. Now how will we represent these sets? We have to represent these sets. So see, there are two methods by which we can represent the sets. The first is tabular or roster form. You have already studied about this tabular form. And the second is set builder form. Yeah. It might be a bit of you might would be facing a bit of problem because I was not able to make the PDF of this session because this is the first class. This was the basic class, so I thought not to put up a lot of things. So I just thought I would just make the things clear to you so that you can learn the things. So rather than not going like taking screenshots and all, I'm just telling you all the method, all the things which is required to learn in sets. So the first thing comes on here is tabular form. So the meaning itself says making tables. So in this method we just write या describe the element in some commas या फिर in commas within the braces, in comma within the braces. And suppose if we are given a set of natural numbers, it is being represented by n. You have already studied this in class 9th 10th. So these contains 1 2 3 4 and so on. So if we put braces on here, so this is what tabular form means. This is what tabular form means. This is what tabular form is. This is what is tabular form. So if we are given a set and if we differentiate the elements of the set by commas, and if we keep it in braces, inside the braces, so that is what is tabular form. So now moving up to set builder form. Now see, this is a very different kind of thing. This is a very unique thing. You just need to learn a simple thing in this set builder. It means you have to give some information, or you have to write that within formula. You have to write that set in terms of some formula, in terms of like 2n plus 1 x plus 1 n plus 1 x plus 1 a plus 1 a plus b, this type of thing. So if we have to represent a set in terms of set builder form, then a is equals to x, where now if I say where x belongs to n, so here we have given a definition to this x. So now we just don't have to write 1 2 3 4. We've just given a definition to this set. We have just written here x and we have given this definition to x, that x belongs to natural number. Now every natural number comes in place of x. So this is what set builder means. We have to define, we have to give a variable or some formula in terms of variable to the set, and then we have to define that variable here. So this is what set builder form means. So now we'll learn about different types of sets. So what are these different types of set? So the first in the row comes null set. Now you know what null means. So null means nothing. So there will be a set which will be nothing. So there will be only braces. Means there are no elements in this set. So this is called as null set. We represent this set by using the symbol phi. You might be aware with this element phi. So if suppose for example if we take an example, so if we define a set A is equals to x is a prime number between 90 and 96. So you know there are no prime numbers between 90 and 96. So this A will be is equals to phi. So this is a null set. This A is a null set. So now second in the number comes singleton set. What it is? Singleton set. So this again, this word singleton defines itself single. So you would also might be single in your lives. So single means only one. So there is only one element present in the set. Only one element present in the set there. So gentlemen, if you like me to go with to take classes in Hindi language also, so you might comment it on, but I am carrying it in English, as if you qualify the written examination of this, so there comes a stage which is known as SSB. So English is very much required there, so that is why I'm trying my best to make it in English, to continue this in English. So if you want your classes in bilingual language, so you can comment on. So now what this A means? So suppose I take a set A is equals to 0. So this is not a null set, gentlemen. This is not a null set. So you just don't have to write it null, because if so see this is really a lot of students get confused in this. So if 0 is kept inside, then they put it null set. No, this is not null set, because 0 is an element here. 0 is an element here. Null set means there will be no element present in that set, but 0 is a element. 0 is a whole number. So here this will come in the category of singleton set. So now third in the row comes finite set. Finite set. Sorry gentlemen, my handwriting is not so good. So see, what is finite set? Then what the word finite means? So see, a finite means a fixed number of elements. Like if I say A is a set of vowels. Suppose A is a set of vowels. So there are fixed numbers. There are only 5 vowels we know in the whole alphabet, in the whole English alphabet. So this is what a finite set means. So there will be A, E, I, O, U. So these are the five vowels. So if we say set of all vowels, then this is a finite set, because the number of element here is fixed, that is 5. So this is what finite set means. So now gentlemen, here comes one thing that is called as cardinal. This is called as cardinal. Somewhere it is in some book, it is written at cardinality. Sorry, I have written it wrong, so I'll correct it now. Where is the eraser? So cardinal number. So the number of elements present in a finite set is called as cardinal number of that set. Yeah, you have to remember one thing. You have to remember, not you have to focus on one thing, that it is here finite set. So finite set, cardinal number. So this finite set, because if the set is not finite, if the set is infinite, then you don't know how much number of element is present in that set. So if we have to find the cardinality of any set, or if we have to find the cardinal number of any set, then it will always be a finite set. There will be no infinite set, because if we have not talked about infinite set, we will just talk about infinite set. But number of elements present in any finite set is called the cardinal number. So if we talk about the cardinal number of this set, that set of vowels, then the cardinal number of this set is 5. So there are 5 elements present in this set. Okay, gentlemen. So now we'll move ahead. We'll take up a new page. I think it is not available from here. So just erase it. Okay, gentlemen. Then we'll talk about now infinite set. So what are infinite set? So if the number of elements are infinite, means there is unlimited number of elements present in a set. And there is unlimited number of elements present in a set, then that set is called as infinite set. Like suppose if we take an example and we'll write here x is to x belongs to n, then this is a infinite set, because we really don't know how much natural number is present in this whole number system. So now we'll take up the next, which is the fifth one, that is equivalent set. Equivalent set. Now see, if the cardinal number of two sets, please clearly listen this. If the cardinal number or cardinality of two sets are equal, see, the elements should not be equal. It should not be like a is equals to 1 2 3 4 5 and b is equals to 1 2 3 4 5, then only they'll be equivalent sets. No, if the cardinal number of any two sets are equal, then they are equivalent sets. Now see, we represent this. If suppose a is equals to 1 2 3 4 5, so we represent the cardinal number as na. We represent the symbol of cardinal number is na. So cardinal number of this set is 5. Yeah, and we can also say this as cardinality. So if a set b is also there, which have 5 elements like a, e, I, o, u, so the cardinality of this set is also 5. So here a and b are equivalent sets. So here a and b are equivalent sets. So now I think I am clear with this. Now we'll move up to next, that is equal sets. So now here comes the sixth one. That is equal sets. So see what equal sets mean. See, in case of equivalent sets, there were only the number of, see, the cardinal number were equal, but in equal sets the member of a and the member of set b should be equal. Like if suppose a have their member as 1 2 3 and b has 3 1 3 1, sorry, I'm unable to write it here, so I'll just erase it and I'll write it here. And if suppose b has 3 1 2, now see, a is also elements as 1 2 and 3 and b also has 1 2 and 3, so these both are equal. They are equivalent also because their cardinal numbers are equal. So from here see, they are equivalent also because their cardinal numbers are equal. So from here we infer that equal sets This is a point to be noted, so you can note down. So equal sets are equivalent. Equal sets are equivalent but equivalent sets need not be equal. Need not be equal sets. So all equal sets are equivalent because their number of elements are also equal and their members are also equal. But in case of equivalent sets, only their number are equal, so their cardinal numbers are equal. So every equal set is an equivalent set, but every equivalent set need not be equal set. They may be equal and they may not be also. So this is a point to be noted. So now let's move ahead. Now the seventh one comes on as, so sorry, this is seventh one. I've marked 8 here. This is seventh one. So the seventh one is, so the seventh one is subset. So the seventh one is subset. Now see what this subset is. Now what this subset means. So now suppose if you have A and B as two sets. So if B, suppose A. So let's take an example. Suppose if A have 1, 2, 3, 4 and 5 and B have 1, 2, 3. So here you can clearly see, here you can clearly look that all the elements of B are present in A. All the elements of B are present in A. So here we can say that B is a subset of A. B is a subset of A. This means that all of B is contained in A. All of B is contained in A. So this is what subset means. So here is a formula. So here is a formula which you need to remember. So here is a formula that you need to remember, that the total number of set, this is a formula to find total number of set of a finite, total number of subset, total number of subset, total number of subset of a finite set. Again I am using finite set here because we don't know the number of elements in an infinite set. So the formula is 2 to the power n. So the formula is 2 to the power n. Here n is the number of elements present in that set. So here n is number of elements. N is number of elements. Okay gentlemen, so let's move ahead and let's get to the another one, that is eighth one, superset. Eighth one, it is superset. So now what this superset means. Now see, upside again, let's take an example again. Let's go and repeat the same thing because it is better to understand from an example rather than going on that theoretical lectures one. So now take this. Okay, so see, again we can see that all of the B, all the elements of B is contained in A, so we can say that B is a subset of A. So again, B is a subset of A. This is the symbol of subset. Then we can say that A is a superset of B. A is a superset of B. A is a superset of B. Again, so this is vice versa. So if B is the subset of A, then A will be the superset of B. If A is the subset of B, then B will be the superset of A. This super means superior. Okay. Okay, gentlemen. So let's move ahead and let's come to proper subset. Now, what does this proper subset mean? So this proper subset mean that if A is a subset of B and A is not equal to B, then it is written at, so now I'll tell you how it is written as. So if suppose it's the ninth one, so if we take an example, and so we'll again understand this by example. This is proper subset. So now let's see what this proper subset mean. Suppose if you take an example, A is equals to 1 2 3, that's it, only this much thing. Okay, so this proper subset mean if A is a subset of B, so if this equality sign is neglected, means if A is not equal to B, A is not equal to B, then it is a proper subset. So suppose, so then it will be written as A is a subset of B. So this is called as proper subset. Proper subset. I know you not have understood this. So to make you understand this thing, so if suppose if A is 1 2 3, then all the proper subsets of this A is, the first one is 5, second one is 1, third one is 2, fourth one is 3, fifth one is 1 2, sixth one is 2 3, seventh one is 1 3, and will not take 1 2 3 because we have already seen that it should not be equal to that set. It should not be equal to that set. So the total number of proper subset of a finite set, again the total number of proper subsets of a finite set is equals to 2 to the power n minus 1. That minus 1 is the last one, where we have to neglect the value, which will neglect the set which is equal to that set. So it should never be A is equals to B. So this is what proper subset mean, and this is the formula. And again, n is the number of elements, and here represents the number of elements present in that set. So now let's move ahead and let's see what's next. So the next is universal set. Next is universal set. So now what this universal set means. So see, this word even tells you everything. This word gives you the vibe. This word tells you what it is. Universal. So all the sets present in this universe, all the sets present in this universe is called a universal set. If suppose if I have taken A is equals to set of vowels, so here universal set will be alphabets. Universal set will be alpha. Universal set will be alpha set. So it is stated that all the sets under consideration are likely to be subsets of a set. Means there is always a set which is superset of every other set given to you. If suppose you are given with a set A, then then A also will be a subset of a set which is called as universal set. So we have also taken an example to tell you, if suppose, let's take another example. If suppose you have a set A is equals to 1 2 3, B is equals to 4 and 5, C is equals to 6 7 8. So there is a set, there is a set which is present, which is superset of all these three, which is superset of all these three sets. So this is what universal set means. That ऐसा समझ लो, मतलब इसको इस तरह से समझो कि सबका ये बाप है, इस तरह से. He is like Sachin Tendulkar. Every class of shots he have, every type of cover drive भी खेल सकता है, long off पे भी छक्का मार सकता है, this type of thing. So this is what universal set means. This is what universal set means. सबका बाप समझ लो. You are given any set. So this thing, there is a set which is superset of this set, and that is what universal set is. So now I think I'm clear with this. So now let's move ahead and let's get to the last one, that is power set. That is power set. So what this power set means: all the possible sets of a subset, all the possible sets of a subset, all the possible sets of a all the possible subsets of a set, all the possible subsets of a set, all the possible subsets of the set. So if suppose I have been given a set A is equals to 1 2, then all the possible subsets of this set will be called as power set of A. It is denoted by P A. It is denoted by PA. The formula is again to find the power set is 2n square, where n is equals to number of elements. So if we have to find the number of the power set of this A, then that will be 2 square is equals to 4. So there will be 4 sets, there will be 4 subsets of this A. So this means there will be 4 subsets of set A. There will be 4 subsets of set A. So gentlemen, we are finished with the types of sets. So now we'll be moving on some important properties of set. Some important properties of set. So what are these important properties mean? So if a set A is given, if a set A is given, so if a set A is given, then A is a subset of A. It means that A is a subset of A. Means every set is a subset of itself. So this is what a property is. Again, the second property, every set is a subset of its universal set. Okay, every set is a subset of universal set. Okay, I've already told you about what universal set is. Now the third property is, so actually this is type of revision type of thing, so that is why I'm not taking so much of basic class, but it is just a start, so that is why you will not see a lot of good stuffs like PPTs and all. But wait for the time in 1 or 2 months when we'll be experienced in doing all these things, then we'll improve ourselves, we'll improvise in all these things, and we'll try to provide you with all the PDFs and all. Everything will be given to you and every type of help will be rendered. So now the third comes is phi is a subset of A. So if I have already written in the starting, if set A is given. So phi is a subset of, actually phi is a subset of every set, and every set is a subset of universal set. So you have to remember this thing, that phi is a subset of every set, and the second point is every set is a subset of universal set. Okay, so now the fourth property is a is equals to b. If a is equals to b is given, then a is a subset of b and b is a subset of a. So if a is equals to b is given, then a is a subset of b and b is a subset of a. Both are true. Both are true, both are applicable. Okay, so now here comes the most interesting part. Here comes the most interesting part in sets, that is Venn diagram. Venn diagram. So here comes a Venn diagram. See, Venn diagram. So what is Venn diagram? Venn diagram is a type of pictorial representation to express the relation among two or three sets. Two or is relation among sets. It is a pictorial representation to express relation among sets. Among sets. So this is what Venn diagram means. Venn diagram is pictorial representation to express relation among sets. So generally, when we make a Venn diagram, if suppose we are given with a set A, so we have to represent this set A using Venn diagram. Then first of all, we'll draw a rectangle like this, and we'll represent this set A as a circle in between. So this is what A is. Now what this rectangle is, this is what is universal set. So every set is a subset of universal set. So now here we will learn all the things, all the operation on sets using Venn diagram. All the operations on set using Venn diagram. So now let's start with the first one, that is union of sets. That is what? Union of sets. So this is union of, so what this union of set is? So first of all, we'll represent this union of set is like with this symbol as U. So suppose if we talk about what union is, so first of all I'll make a Venn diagram, and then after I'll take an example, and then we'll tell you what this is. Okay, so see, the Venn diagram for union of sets is like this. If suppose we are given with set A and B, so first of all we'll draw this A, and then we'll draw this B. This is universal set, this is set A, this is set B. So the union of set means this part, the part I am shading. This is the part of union of sets. This is the part of union of set. So suppose now see, this is the diagram of union of set. Now I'll I'll give you an example, and then I'll tell you what this union means. So if this is a set A contains 3 numbers, and set B contains again 3 numbers, suppose 3, 4 and 5. So A union B means, so if we make A union B, so it means that we have to write every number present in A and B, but the common numbers will be written only once. So 1, 2, 3, 4, 5. So if we try to represent this on Venn diagram, then we'll write 1, 2 in this part, 3 in this common part, and again 4, 5 in this part. So this 3, 4, 5 is in B, this 1, 2, 3 is in A, and all, and so on. This is what union of set means. This is what union of two sets mean. So now we'll talk about intersection of two sets. Now we'll talk about intersection of two sets. So now we'll talk about intersection of two sets. So now what this intersection of two sets mean? So first of all, let's draw the Venn diagram. Again, we have taken those two sets A and B with the same. A contains 1, 2, 3. B contains 3, 4, 5. Okay. So again we'll make A, B. So this is A, this is B, this is universal set. So here this shaded region, this is what A intersection B is. So we'll represent intersection of two sets with this symbol. So this is what A intersection. It means we'll take the common part, common element of the two sets. So here if we write A intersection B, then we'll get the answer as 3, because 3 is the only element which is common in A and B. So this is what intersection of two sets mean. So now let's move ahead and go see what is the next operation. So the third one is disjoint set. Third one is disjoint set. The third one is disjoint set. Now what this disjoint means? So this word disjoint only says that it is not joined. So the Venn diagram. So this means that A intersection B is phi, means A intersection B does not exist. So if we make the Venn diagram for this, so if we make a Venn diagram for this, then it will be like A will be here and B will be here. These both will not be joined by each other. So if we take up an example, so suppose if we take up an example, then in set A 1, 2 will be there, and in set B if we keep 3, 4, then these both sets are disjoint, means A intersection B is equals to phi. A intersection B is equals to phi here. So this is what disjoint set means. Now here comes, now next up in the, so next comes difference of two sets. Next comes difference of, so I'll not be writing now two sets because it is taking a lot of time. So now difference of two sets. So you know from your childhood, from class 2 3, that what is the sign of difference. So that is this minus. So we'll use here minus only. So see, the Venn diagram for this is, so this is very simple. This is very simple. You just have to understand a single thing and you'll get what this difference mean. I think you might be knowing about all these things, but this is a class for basics, so that is why I'm telling you all the things, but not in that detail because we are left with very less time. So suppose if these are the two sets A and B, this is universal set. Again, A is 1 2 3 and B is 3 4 5. So see now what difference means. So if suppose if I write A minus B, if I write A minus B, okay. So if I write A minus B, so this portion A minus B means we'll cut out the part of B from A. So these are the part of, so here A intersection B is the part of B in A. So we'll cut out that part. So the left portion will be like this, खाया हुआ सेब की तरह ऐसे. So this is what A minus B looks like. So if we write it by numbers, by taking the elements, so A minus B will be only 1 and 2. So we can write this now as A minus B is equals to A minus A intersection B. We are carving A intersection B out from A. So again, now for B minus A, what it will be? B minus A, it will be B minus A intersection B. Okay, so we'll carve out again A intersection B from set B. Okay, so this is what difference of two sets mean. Okay, gentlemen. So again, so now we are left with just two operations. So the next one is symmetric difference. So the next one is symmetric difference between two sets. So symmetric. So first of all there was difference, now this is symmetric difference. We represent this by symbol triangle. Triangle is the symbol for this symmetric difference. So if we have to find the symmetric difference between two sets, so we'll write like this: A symmetric difference B. Now what does symmetric difference mean? Now tell me what this symmetric difference means. See, this is very simple. You will get it when I'll draw it in Venn diagram. See gentlemen, Venn diagram is a very simple thing and most of the set questions will be solved by Venn diagram. So rather than mugging up the formula which comes in, see, NDA generally gives some questions which is based on the properties or formula. Okay, so you just have to learn Venn diagram properly. So you'll just not need to remember or memorize all the formulas of sets or relation or function. Also it helps in some questions, few questions of relation and function also. So this is a thing which you have to learn. So if you learn the Venn diagram properly, it will be very easy for you. I'll be coming with those classes also, with those questions also, and then we'll tell you how to solve all that questions from using Venn diagram. Because see, this is not an exam where you have to write the process to solve it, which formula you have used. Nobody is taking care of what formula you have used. So it is all about how you find the right option for you. So this is Venn diagram is a way to find out to find the options, to find the answer from the options, to find. So this is a very good thing, so you should learn this properly. So see, now again this will be set A and this will be set B. So this is set A, set B. So now see the area I am shading. So this is what symmetric difference means. See, this is the area which is A minus B. This is the portion which is B minus A. So A symmetric difference B is equals to A minus B union B minus A union B minus A. This is what symmetric difference means. This is what symmetric difference means. Okay, gentlemen. So now let's move ahead. We'll not be taking example in this because this is very simple thing. So if you want me to take an example, so let's take an example. If suppose a set is there, A, again same, A is equals to 1 2 3, B is equals to 3 4 5. So the first of all we'll find A minus B. The A minus B is 1 2 and B minus A is 4 5. So asymmetric difference B will be 1 2 4 and 5. So this is the answer. This is what symmetric difference means. The union of A minus B and B minus A means the common part will not be there. So you have to if you want to remember, if you want to make it fast, so A intersection, so asymmetric difference B will be, you just don't include the common part, don't include the common element, and the rest of the elements of that both will be your symmetric difference. See here you can see 3 is the common element in A and B. So here in symmetric difference 3 is not included, rest every element has been included. So you can also figure out all these things. So now the next thing comes complement. The next thing comes complement of a set. This is very simple, and the sign used for this is either they will write like this or it will be written like this, complement. See, this is a very simple thing. We have already learned about complementary angles in your junior classes, so this is not much hard. So you just make up a Venn diagram, put here A and put here U. So all the portions excluding A, all the portions excluding A, all the elements excluding A is the complement of A. So if suppose A is 1 2 and universal set is 1 2 3 4 5, then A complement will be 3 4 and 5. Okay, gentlemen. Then so now we'll move up to the next thing, which is law of algebra of sets. Law of algebra of sets. So we'll take 10 to 15 minutes more and we'll complete this. But now I think the video has got a bit lengthy. It has gone to 55 minutes or so. So if I start teaching you laws and few important results are there, so it would really take half an hour. So the video will get a bit lengthy, a bit more lengthy. So now we'll take one more class for the basics of set theory. and we'll complete with laws and these important results, few important results, and I'll tell you now in these important results and laws, then I'll tell you how it is being checked through Venn diagram, whether this is true or not. Because see, NDA will never ask you the derivation of any law, any formula, any result, but it will give you that in option that whether it is correct or not, or choose one which is correct. So if you have that knowledge of Venn diagram properly, so you'll figure out, so you really don't need to remember all these important results or law. You'll just figure out it through the Venn diagram. So okay gentlemen, as of now, a very very good night to you all, or whatsoever, good morning and good afternoon, and so at whatsoever time you are watching. So signing off from here now. Thank you from the core of the heart. Thank you from the core of the heart to for attending these classes. We will be bringing more lectures on math, science, and when for your GS parts also. So if you want to follow this channel for your NDA preparation, so you can. It is a start, so there will be a lot of problem in the starting, but we'll figure it out. We'll improvise it and improve upon ourselves, and we'll see what we can do for you. So thank you gentlemen, thank you, good night, good morning, or good afternoon at whatsoever time you are watching it, and bye. Thank you.